guys, I'm Abdul Mohani. I'll be taking you on biostatistics. Please calm down, rest, and watch the video. Now, what is biostatistics and why is it relevant for us? Biostatistics is a branch in science that is so important in order to evaluate our functionality or works that we will be doing, either based on any field. Because it is very important to understand the statistical value of living organisms. But before I fully explain what biostatistics is all about, we need to understand that there is what we call inductive inference. Inductive inference simply means making an observation or deducing an observation or conclusion from raw data that you can actually see from a large number of population. Let's say you want to take deducing a conclusion from an observation. This is known as inductive inference. It is very, very important, as every observation that we make or you can see is what you are going to draw your calculations or your conclusions from, as all the whole population cannot be taken, irrespective of what you will be working on. So this is very important to know first. Now, what is statistics itself? Statistics is now the way we calculate from what we got from our inductive inference. How do we calculate? How do we strategize from what we have gotten? So, our statistics is the way we calculate the values from our inductive inference. So now when you want to now make statistically, everything is statistics. How do you arrange the data you've gotten? How do you arrange the observations that you've gotten from a particular or large number of population? You make use of statistics. It makes you organize and deduce what a particular problem is entirely in any field you are working with. But specifically, we are working on biostatistics, that is life. So, applying these techniques of statistics in living organisms is known as biostatistics. So biostatistics is when we apply the knowledge from statistics to solve biological problems. It can be of any type. And there are sources that we will be need to do all this. First, we need to understand our data. We need to understand what variation is. And we need to also understand what character is. So now let's start with the data. What are data? Data simply means your source of items from what you have observed. So when you want to take statistics of any place, you need to have source of what? Items. What you are going to be working with from a particular sample or population that we talked about, you are going to be picking up some data from them. So those items you pick from the areas you are working on or from the observation you have seen are known as your data. So what are these source of data? Source of your data are dependent on your variation. So your variation will give you the type of data you are going to be getting. So for source of data, so we said already that our data are items we got from our observation. Observation, okay, let me just write it here. Now our variation is a source of data. So technically, the source of data we have is our variation, because you can't get your data without having variation. Now you might like to ask me, what is variation? Variation simply means differences. Variation, so you look up here. Variation simply means differences in the observed items. So differences in the observed items we are working on are source of our data. Because let's say you are working on the blood of human being, you need to understand that there are differences in this blood. So for example, working on the blood of human being, for example, when you're working in blood, we have different types of blood. We have different types of blood group. Let's say we are talking about blood group, for instance now. We have the blood group A, B, O, and so forth. So having these differences makes us to know how to deduce our value. Now, the character is the last aspect. So the source of our variation is what? Character. Character is the source of our variation. So I said that we are going to be getting the differences. So how do we get these differences in the population we are working with? We are working on human blood, for instance now. How do we get the differences in this blood? It's the character. So the characters of the blood will now tell us which human being has this particular type of blood and which one has this. So coming down, it will now reflect us back to what we call this blood group. So when I am through now, you will be able to tell. When you are through with your statistical work, you can be able to bring into conclusion that after working with the character, first of all, remember, we get our data, then the variation, which is the differences, then the differences, the sources of these differences are now the characters, which include the blood group that each and every individual is, A, B, and O. So you can now come into conclusion and say that, okay, this is also number of organisms, for example, a percentage or a particular percentage of organisms are having this blood group A, or a particular percentage are having blood group B, and a particular type are having blood group O. So you see, this is how we carry our biostatistical work. So having understand this, we are going to be moving into the variables. We are going to be understanding the variables. So, variables. Variables simply means differences that is constant in every entity. So variable is our differences that are constant in every entity. So there is nothing we are working on that do not have variable or differences. But how do we distinguish this? How do we distinguish one variable from another? How do we tell whether this variable can be measured or cannot be measured? So we will be looking at that now. We have different types of variables. The first one we'll be talking about, we have the qualitative variable. and we have the quantitative variable. So let's talk about the first one, which is the qualitative variable. Now when we say qualitative variable, what comes to your mind? Feel free and pause the video when you know that. Qualitative variable simply means when variables that cannot be measured and that has no magnitude. Some variable cannot be measured, they are not in numbers, then we call it qualitative variable. Okay. So the qualitative variable, okay, pointing at the arrows, these are variables that cannot be measured and are non-numerical. The non-numerical part of it simply means they are not numbered. So they are not numerical and cannot be measured. And we have different types of these types of qualitative variable. So what are the different types of this qualitative variable? The first one we are going to be talking about is we have attributive variable. So you can see under the qualitative variable, we have attributive variable, and we have the ranked variable. So attributive variables are differences that cannot be measured and has no magnitude. So this type of variable, these are variables that cannot be measured and has no magnitude. So, for example, we have the intelligence, we have different types of this qualitative variable. So there are variables that cannot be measured and it has no magnitude. While the ranked variables are variables that can be measured. That cannot be measured, yes. These are variables that cannot be measured but has magnitude. Magnitude in this sense simply means it has some levels that it can be displayed. It has magnitude. For example, anger. You can see anger can be quantified. For example, you will see that somebody is very angry or somebody is less angry. So you can use that to magnify it, or to say that, to distinguish them rather. So they have magnitude. For example, we have anger. Anger is one of the examples of qualitative variable under the ranked variable. So we'll also be talking about quantitative. From the name, you should understand that when we say quantitative variable, it simply means variables that can be measured and are also numerical. So when we have okay, so we are talking about quantitative variable now, and we said that our quantitative variables, that these are variables that can be measured and has numbers or numerical. So this type can also be divided into two. We have the continuous and we have the what? Discontinuous. So we have continuous variable and we have the discontinuous variable. So now let's talk about the continuous variable. Continuous variables are variables that are in range. They are infinity, they are to infinity. That is, they are continuous. And thus has to be segmented into range. So these are variables that are to infinity and are mostly segmented into range. For example, the age of an individual, the height can be segmented in range. For example, you can say that somebody, the age of a particular, for example, you can say that the age, okay, let's clean this side. So now let's say we are talking about the age of an individual. Age can range from 18 to 28. Okay. So we are taking our measurement or reading from population of age between 18 to 28. Or let's say we are working on the age from 20 to 30 and so on. So you can see that we can actually, we don't know how many they can be. So they are infinity, they are continuous, but we can take their measurement when we segment it into range. Or we also talk about height as well. Like these people's height ranges from 6 feet to 10 feet and so on about that. So this is all about the continuous. Now let's talk about the discontinuous. So discontinuous variable, these are variables that has an ending and there is no interval between the numbers. Now example, let's say we write, we have your 1, 2, 3, 4, 5, 6, etc. So this is all about the variable. And now we want to see population. We'll be talking about population as the next thing. So we want to work. You need to understand the type of population you can work on. As a biostatistics, we don't work in anyhow population. We work in a specific range of a particular type of population. But first, what is population? So, talking about population simply means the total number of individuals living together in an area. So this individual is not specific to human being. because our population can be on plant, it can be an animal. So we are not being specific about this individual, any organism at all. But you should know that the total number that is living together in a particular geographical area is all the time as population. So we have two different types of population that we have. We have universal population and we have the biological population. So these are the two different types of population we have, and we'll be able to understand now which type do we actually work on. Talking about the universal population. Universal population. Universal population, this is the population that deals with the entire globe or the population of the world. So this is universal population. And most times you see, taking the population of the world or the entire globe, or let's say you want to take a population of a country, is mostly hard for us to do. So therefore, most times, this type of statistics might not be possible because it is very hard to take a universal population. Now we have what we call the biological population. The biological population is the population of a particular species of organism. So I'm talking about the biological population. This is the population of a particular species of organism living together in an area. So talking about this biological population, you can see that it is very easy for us to take the statistics of this type of population. Why? Because it is subjected to a particular species living together in an area. So biological population, it is what we normally and mostly work on. So this is all about population. In our next video, we'll be talking on sample and everything about it, the calculation and the how we'll be able to deduce our sample and how we can derive our conclusion from our sample. Please make sure you subscribe to this YouTube channel, Learners Connect. Thank you very much and have a wonderful day.